All right, welcome everybody to QuickPass. This is session 5. Today we have Guillermo Aguilar here to discuss the application live coding assessment. So without further ado, here's Guillermo.
How's it going, guys? I think I've talked to a couple of you, maybe on Slack or via email. Yeah, I'm the one that actually assesses your application. I watch your videos, I look at coding challenges, and the last thing is I give you your live technical assessment. So I just wanted to first just go over like 1 or 2 things and then just open it up for questions. Really, the main thing that I want to encourage all of you to do is the same thing that I always encourage, regardless if you're applying for QuickPass or any other method of admission to Platoon, is definitely try to finish your application early. That's probably the #1 mistake that I see. Because typically if you submit your application pretty early, you're going to get feedback from me if you're short on something. So if you're short on quarter byte points, your video, the link is broken, or the link is private, or you forgot to submit it or something like that, you'll get feedback from me if there is enough time for you to fix that mistake and resubmit. So that's the main thing that I really want to convey today. Really try to wrap up the application as soon as you can. If you're good to go, you'll get an admissions email from me. I'll add you to the pre-work channel. I'll send you the link to schedule your live technical assessment. You'll be ready to go for X-ray and FOP, which are the 2 things that come after. So outside of that, I don't really have an agenda. I'll just take any questions that you might have about the application process or the live technical assessment or anything of the sorts.
Hello, Guillermo. I watched the video that was provided with, the preparation for the assessment, and there was a search window that was available, and it said, "Hey, if you want to look something up, you just search it." That's what the person on the video said. Is that still the case? And if
For the coding challenges?
correct.
Yeah, you can search as much as you want. I've refrained from copying and pasting.
Right.
Because sometimes people get a little carried away copying and pasting, and they don't really know what they're copying and pasting. So I'd be wary of that. It's okay to definitely borrow code and try to figure out any which way that you can, but be mindful that what you're typing into that you actually understand.
Right. But if you have a brain cramp and you want to search MDN for some syntax, that's okay.
Are you talking about the coding challenges or the live technical assessment?
The coding challenges.
Yeah, the coding challenges, you can use any resources that you have available to you.
And as far as the live assessment, that's not the case.
No, for the live assessment, there are no notes, just off the dome, whatever you can think of. And I'll be there to lean, you can lean on me. I'll help you through. Really important thing about the live assessment, probably the most important thing about the live assessment is we're testing minimum ability. Like, we have great curriculum, we have great instructors, we'll get you across the finish line, but we just need to make sure that you have the minimum understanding of some basic programming fundamentals. So that's a really important key there.
What triggers the live assessment? Is it when we've submitted the assessment and you've had an opportunity to grade it, and then you're like, okay, let me go ahead and schedule a live assessment with this applicant? Is that what happens is that how it works?
I'll send you admissions email, and I will forward you. I would add you to a specific Slack channel, and on the Slack channel you can schedule your assessment with me. Okay. It's just a Calendly link.
Once we've passed the assessment.
Yes, and we'll be in communication. Like, once you get your application, especially when we get really close to the deadline, really that's the only time really I work hard for Platoon, near the deadline of any of the cohorts, right? So I'm very receptive on Slack, and I know that those applications are coming in. So the minute they come in, they come straight to my phone, and I try to get to it that day. So don't be surprised if you're getting close to the window, you submit your application, then like an hour later, 2 hours later, yeah, you'll have an email from me.
The guy says on the video that you have as much time as you need. If you want to get started on let's say April 20th, and you answer the first one, and it takes you 2 weeks to finish all 10 or 12, that's okay. And as long as you don't you use ideally the same browser, you don't clear your cache or your browser cookies. Is that the case?
That is not the case. That needs to be updated. And the reason why that's not the case is because CoderByte has a 300 application maximum. So when that application gets full, we actually have to just clone the link of the assessment and give out a new link. So those challenges, if you did it, like let's say you were applicant, and you're not going to know this, right? But let's say you open the coding challenges, but secretly you don't know you're applicant 298, right? And you fill out 5 of the challenges 3 months ago, and you're like, oh, you're not applying till Zulu. You got, almost a year, and then you go back to them, only to find out that none of your coding challenges saved. That's what happens.
He said that, yeah, he said that we should, take the solutions that we've done and copy them and paste them onto Google Docs in case this type of thing happens, that we would go back and we would communicate with you, and you would say, okay, you still owe me question 7, 8, 9, 10. And then we would just pick up on 7, 8, 9, 10.
You're gonna have to redo all of them. So that video is old. That's Tom's old video, right?
Yeah,
so the instructor's
right.
Tom. Yeah, those videos are old, and we are actually in the process of trying to redo them, but that takes a bunch of manpower. We're gonna eventually get to it, but those need to be updated for that reason. And again, that's not a constraint that we have. That's a constraint that CoderByte has for whatever reason.
But that could be the case tonight if I decide to start it and I'm applicant 299.
Oh, you guys are not. I can tell you that right now.
Okay.
If you start the application, or you started like a couple weeks ago, it's a fresh link as of like a month ago, and there's only like 20 people on there or something like that.
How long does it stay fresh? Are we talking about 3 months? 2
For
months?
you guys, I'll stay fresh until you get started with X-ray.
Okay. And when it comes to the video, is it just the video, or is there a written part to submit as well?
The video is just a video, but you have to answer the prompts. It's like 4 or 5 questions. I can't remember what they are, but you have to answer those along with the short answer. The application, the reason why I would say start early, it takes longer than you would think.
Okay, so there is a short answer written.
Yeah, there's a couple of short answers, yeah.
And my last question is, when it comes to, let's say, all goes well and someone is accepted, admitted, they're assigned homework, right? Given that, QuickPass is going to end, I don't know, next week, and the next cohort starts maybe a month later, does that give one enough time to get the homework done? And are there any Zoom appearances that are required for the homework?
So there isn't. Everything is actually self-paced. So there's 5 weeks of pre-work in the email you're going to get from me, but really only 4 of the weeks are required. Week 5 is kind of like bonus. If you have time, get to this stuff. But really the only thing that really I think is crucial are the first 4 weeks. And if you get a chance to go up to FOP or watch the videos asynchronously, that would be in your best interest. It would help a lot.
Okay, so if we were admitted and we jumped on the homework, we'd be able to finish before the next cohort starts.
Yeah, that's you would. But that's a question I always get, just how many hours. It really just depends, because some people, allocate, 10 hours a week for, 6 months. And some people, they quit their job, 2 weeks ago, and they have 6 weeks of free work. And, their kid is with their significant other, and they can just go heads down on something 6 weeks. Well, that's way different than if you had a bunch of responsibilities and can only allocate 2 hours, right? It's going to take you long at that rate.
Thank you.
Is this, sorry, I just stepped in a little bit ago. Is this specifically about CoderByte, or is this just about the class generally?
Just generally, yeah.
Okay. So I'm going to be writing an email about this later to, I forgot her name, so my apologies. The person that kind of does the funding and that kind of thing. So I finally got my Voc Rehab email, at least the initial one, the response about that. However, the first time we are set to meet is like July 10th. I had set, I basically just said like, hey, sign me up for either the June 3rd cohort or the one in October. Does that, I'm going to be writing an email to the Voc Rehab person, obviously, as well, just asking like, well, one of the class cohorts that I'm interested in starts about a month before, or a little over a month before the thing. What should I do? Should I, I don't know if I want to, because admittedly, I will be kind of be depending on the funding that I get, or the MHA, basically to just have a babysitter watch my daughter. You know, I don't know what that means because I know a scholarship is paying for this, but yeah, I mean, I guess
So
that's something I'll have to figure out.
yeah, so definitely be in open communication with Tish, but your situation is actually not that uncommon. We've run into it all the time with
I
SkillBridge,
figure,
with
yeah.
scholarships, with like med board that it's gonna clear, it's not gonna clear. Happens all the time actually. So whenever you get the application in, we've had people get approval for their SkillBridge on Monday morning, like 10 minutes before the first class starts. Like obviously you don't want to be that. You don't want that to happen, but that has happened. Like, I mean, last cohort, we had a weird one where they didn't enter their 180-day window until like 2 weeks into the cohort. So they got like, they were burning leave, for the 2 weeks to get them into their window. Like, we will work with you, stay in open communication with Tish, but really the main thing is get your application in. If you're short something, I'll let you know. Once you're good to go, you're going to get that acceptance email from me. Pass your technical assessment when you feel ready, and then you hold the admission, and you can move it a cohort or 2 cohorts if you need to. Does that make sense? Get the full admission, and then you can kind of play with it a little bit.
Yeah. Also, I guess on that, the Coderbyte challenges, I've completed 10 of 12. I haven't, I completed them a little while ago, but it was still past the deadline. That's kind of why I'm here. Plus, I just feel I need the, I need the time on target or whatever. So, I mean, should I just submit them or should I just go ahead and roll right into that 11 challenge? I mean, each one of those challenges, usually there would be like a day or two of like me temporizing and being like, oh my God, what is it? What do they want? What does this mean? Kind of thing. So I'm assuming that's what's going to be taking place. I have kind of a busy next few weeks. We're going to be moving into a new place in a month or so, plus like a bunch of other stuff. So I'm hoping that we can get all settled in and set up.
Yeah, if I'm you, I submitted it, and if you're sure, I'm going to tell you. Yeah, if you're short on something, I'm going to tell you. The only time you don't get a chance to redo it, it's like the deadline is Friday 11:59 p.m. and your application came in at 11:58. You're not going to get an email from me. You're just going to get a rejection. You can't. I'm not even going to get to sending you an email, and then the deadline's going to expire. Right? That's the only time you don't get it. And this is not true. This is true for This is true for the application progress here at Platoon. Whether you applied to QuickPass, or you applied last year or this year, that's just the policy that we have here. Even if you give me like a day ahead, you'll get an email from me pretty promptly. But like, hey, if you can get it in before midnight, we can take you.
Okay, cool. Thanks.
Any other questions, guys?
Well, I've been told that there are no such things as a stupid question, so I have to ask Guillermo, is this really you or is this Michael Pena playing Guillermo Aguilar?
Who's Michael Pena?
You don't know Michael Pena, the actor?
No.
Okay, look him up.
I mean, vaguely he looks like Michael Pena, but I think it's a bit of a stretch.
He kind of does.
Oh, a little bit. Yeah, I know who he is.
Knows.
He played Cesar Chavez in that movie. I really like that movie. Right? That was the actor, right? He played Cesar Chavez, the movie?
He was in several movies.
Yeah. Well, I got a question. I'm not sure. I haven't seen this assessment video, and I'm also not sure if this is too far behind the curtain or whatever, but besides procrastination, do you find a lot of common mistakes? Like usually people get hung up on one thing and you're like, oh, you were super close, but you missed this in particular? Or is that something you can't answer as well?
Actually, I was going to answer a little bit of this, someone else's question. I think it was Thomas's question. So just so you know, for full transparency, you get 12 challenges. The reason why we recommend 10 is because we think those 10 are within your ability, even if it's a stretch a little bit. 2 of those are outside of your skill set. They're meant to stretch you. We don't expect you to get any points on those, right? That's just how the application is built.
Oh, I was gonna ask, was one of them actually like within those 10? Because I'm pretty sure I can think of like 2.
No, I don't talk about the application because it's not something that we do in Copenhagen. But just know that that's the reason why we recommend 10. We know that 2 of those are outside of your range, and that's perfectly fine. That's what I can share.
Hmm.
Any other questions, guys?
Guillermo, are there any kind of like minimum skills that you recommend they have, or that you kind of direct folks in the application to kind of know when they walk into the like live coding assessment? Like, are there any kind of, the skills
Yes. Yeah. I'll go ahead and you're assessed on the following things. You're assessed on loops, variable assignment and reassignment, manipulation of strings and arrays, and if you get to it, key value pairs and dictionaries. Those are the 4 things that we assess. A fundamental understanding of those 4 things. Why those 4 things? Because you're going to realize that everything in programming can be done with those 4 things. If you know regex already, awesome, but you actually don't need it. It's just a loop underneath, right? If you know a lot of those high speed, high order function from JavaScript, that's cool, but you don't need any of that either. It's just a loop underneath too.
Can you repeat the 4th thing?
Yeah, I'll say them all 4 again. Loops, variable assignment and reassignment, manipulation of strings and arrays, and then key value pairs in dictionaries. Good question, Aaron. I forgot about that.
And conveniently, those are the things we teach in QuickPass. So watch the videos, do the assignments. You'll get plenty of practice in those 4 things to help you succeed.
Yeah, it looks like there's a question in the chat for you.
What's your background? Everyone that comes to Platoon has some kind of military background, or they're a spouse. Probably arguably a harder job than being in the military. I live in Austin, Texas right now, but I actually grew up in Aurora, outside of Chicago. I got tired of shoveling snow as a kid, so eventually I came here. Just like many people here, I actually don't know Aaron's background that much, but he'll share it with us here after this. But you're going to realize that and this is actually a pretty common question too, most of the people that come to Platoon, they don't come from technical backgrounds. None of them. Like, some people have IT experience, but what I have found out that you come from IT experience, what I have found is that there's like this false sense of confidence that comes from IT that you think you can transition into being like a raw, like productive coder. And the skills don't really translate that well. If you help your grandma with your printer, it doesn't mean you can write, multiple table joins in SQL or, build a full stack application. Those skills don't really translate. So it's almost better that you come from either a computer science background or no background at all.
I can attest to that. I agree.
Yeah.
I agree. I work in IT, and people that work in IT do not like programming.
Yeah, it's kind of weird, but I don't know where that comes from. There's just a lot of confidence from people coming. Truth be told, and I'm glad this is being recorded, there's been one person that come from IT that could actually code. He graduated here in Victor. I'm not gonna dine him out, but there's been one, and there's been, man, I don't even know, like 60 maybe people with quasi IT experience in the 2+ years I've been here. So those numbers aren't very good. So if you don't come from any kind of technical background, don't worry about it. I used to be a history teacher. Aaron, what did you used to do? I actually don't know.
So I was a weather forecaster in the military. So I did 21 years of weather forecasting, and yeah, decided to dive into software engineering.
Dude, that's awesome. So I kind of want to get my pilot's license. And when you talk to pilots, you're like, oh, flying a plane is easy. But the weather patterns and understand how to fly in them, that's the hard part.
Yeah.
So you ever talk to pilots, flying and plane, it's nothing. But figuring out the weather stuff, that will get you killed.
Yeah, I have a quick question for you.
Mhm.
And I agree on that IT stuff too. I was a network engineer, and let me tell you, this coding shit is a little rough.
Different. Yeah.
It's different. Trust me, it's different, right? So I don't know what the hell it is, but it's different. But I want to take my, what is it, the technical assessment. So I want to start Friday. So just go ahead and fill out what it is that I need to fill out.
So So you can't actually take the live technical assessment until I
No,
have a
no.
complete application.
Okay, no, that's what I meant. So I'll go ahead and fill out the application to be able to do the skills assessment because I was a little confused on that.
Yeah. So once you get
The coding
once you complete,
challenges.
yeah, once you complete the full application, you'll get an acceptance email from me. Be like, here you go, and you will get access to the link. It's just a calendar link. You go in there and you find whatever time works for you.
Okay, so let me get this straight. Okay, so just for the assessment, I was looking online, right? So just go ahead and fill out the application, and then you can send me a link to take the coding challenges or something, right?
Yeah, the minute that I accept you, I'll add you to a Slack channel, and then the Calendly link is bookmarked. Just like how you guys have your Zooms bookmarked in this channel, it's exactly like that. Except it's just a Calendly link.
Okay. Well, one more comment on the IT to software. I think what the difference is like I was a Cisco guy, right? And a lot of it is memorization, understanding configurations and stuff like that. Whereas you don't do as much, as far as configuring, because there's a lot of copy and paste. Whereas in the software, the coding stuff, man, I mean, it's like digging ditches, muscle memory. That's what the difference is. That's what I've noticed. That's what's difficult to make that transition. That might help.
Yeah, that makes sense. I have no IT experience, but that sounds
better.
right.
It's better because you don't know what to expect.
Yeah.
I almost wish I didn't have any IT experience. And I was cocky, but I got my ass handed to me. So I'm not cocky anymore. Thank you very much. Appreciate
You're
it.
welcome.
All right.
Quick
And
question. I was
I'll
just going
just
to
say one thing. Like,
go ahead.
I just say one thing. Like, so I used to be a teacher. In teaching, there's this really famous. You can research it. It's a really famous study where they asked, but it's like a really famous study. They asked a bunch of teachers if they thought they were better than the average teacher, and like 70-something% said yes, or like 80% or something. I was like, statistically, that's impossible. But that's kind of how it feels sometimes. You know what I mean? Like the numbers don't lie, right? It's impossible for that many people to actually be above average, right? It's a little of that going on. Sorry, go ahead, Len. Or Thomas, or
I have a question. What you said? Loops, variable assignment, and reassignment, and what else? What the third one?
loops, variable assignment, and reassignment, manipulation of strings and arrays, and key value pairs in dictionaries. There you go. Emerson's got it.
Thank you.
This isn't I mean, hopefully there's a question out of this, but the week prior to the beginning of QuickPass, I was scrambling and I tried to do the 12 coding challenges or whatever on the second part of this application. And I struggled for like 2 hours in the first one. And just the time I've spent here, and I'm working on the exercises with my brother who's programs, I feel way more confident, but I'm still like, I don't know if I'm like at all close to where I want to be or if I'm like where I should be to be ready for the live stuff. If that makes sense. Like, how do you assess yourself?
That's a pretty good question. I'm going to answer it in a not so great way because right now you're really tight on time. But typically, the advice that I always give is like wherever, like just sit down by yourself and analyze where you think your skill is. It needs to be twice as good typically when you code in front of someone because you're going to forget half the stuff that you know when someone watches you code. And there's nothing wrong with you. That happens to everybody. Everyone lays an egg when people are watching them code. Why? I don't know, man. People get nervous.
That makes sense.
That was pretty much what my question was going to be. Like, because I'm already like interviewophobic or whatever. So, being asked to explain something I just learned or figured out or, looked on Google or whatever. Yeah. It's like,
yeah. So you need to get into the mindset right now that this needs to be something you're going to be pretty good at. Because in a very short period of time, you're going to be in front of people and they're going to be you're going to be going through a whiteboarding or you're going to get, this is actually super common. And I'm sure Aaron has gone through it. You'll sit down, it'll be like 1 or 2 people, sometimes more. And they'll just ask you like, hey, explain a promise to me. Tell me the difference between Git and GitHub. If you have this Git issue, what would you do to fix that? They're just hitting you with these like rapid fire attack questions, right? You built an application, right? And you only have 10 users, but you get a TikTok ad, and all of a sudden you have, 10 million users. 24 hours later, how's your app going to handle that? You know, like, and I just give you examples of all interview questions that I've gotten before. Those are real. You're going to have to answer that, you know? So start getting good with it now.
Guillermo, quick question on JavaScript versus Python. When you gave us those topics, you mentioned key value pairs and dictionaries, but if we do JavaScript, we'll deal with objects instead, right?
Yeah, they're synonyms. Dictionary, map, hash
When
map.
we do the 12 problems, can we do some in JavaScript and some in Python?
No, stick to
No?
one. Stick with one.
Okay, and when we do the live assessment, we can only use one language, not
Yes. Surprisingly enough, that's not the first time I've gotten that question.
okay.
You stick to one.
Sometimes, you know, the Python solution comes to you, and sometimes the JavaScript solution comes to you, and, you know, all right.
You guys are picking a good first one, because typically anyone that's ever been really good at technical challenges always does it in Python. Why? Because it's fast, and there's a lot of built-in functionality into the Python language that allows you to solve things quickly. And typically when you get to those assessments, it's not a matter sometimes of whether you can solve them, because given enough time, pretty much anyone can solve them, right? But you only have 30 minutes, you only have 40 minutes. Not a lot of people can solve them within that time constraint. So Python's a go. Get good at it.
Okay, I have a question, please. One more question, please. I already started the code challenge. I solved the first problem, okay? But I solved it before I start the QuickPass, and I solved the problem with the JavaScript because I start with the introductory course that Greg sent it to me, okay, the link, the one on the website. So after that, I stopped. I said, okay, let me be with Aaron, okay? And I will solve the code challenge with the Python. Now you said I have to finish it with JavaScript.
No, you can finish it. You can, like, if you take this Python course, but you submit your application in JavaScript, I suppose you could do that and I'll grade it just the same. But you can't really mix them. And why is that?
No, I'm not gonna mix it. I solved the first one, but in JavaScript. Then I start with Aaron, okay, and I stopped finishing the JavaScript, the introductory course, and I want to solve the other 11 problem with the Python. Is this okay?
You need to solve all 12 with Python. And the reason for that is they come in as different submissions. You get what I'm saying?
Yeah, but,
like if you did the first 3 in JavaScript and then the last 9 in Python, that gives me 2 submissions. One with 3 challenges and one with 9.
Okay, so
that's a coded by thing.
So I can restart it with Python?
Yeah, you can.
So I can solve the first one in Python after I solve it already.
Yeah, so there's no limit how many times you can solve it.
I already submitted the first problem.
Yeah, you can submit it again. There's no limit to how many times you can submit a challenge. You can submit it 10 times each if you want.
Okay, that's good. Okay, thank you.
So there was a question or a comment by Jose in the chat. Originally tried to get into the intro to coding and has had the coder byte, though I failed to complete the coder byte challenges. Would I need to apply all over again?
Yes, you need to apply all over again, but if you go into your challenges, if you use the same browser, some of your challenges might still be there. Again, it depends on when we change that link. If it was relatively recently, within the last 3-4 weeks, maybe that's around the cutoff, your old challenges might still be there.
So it's been
no promises.
Yeah, no, I'm okay with doing it over. It's not a big thing. I've learned a lot here in this course and going through these days, and it's also because I really went there to try. It's very confused, and I'm not as confused this time.
Did you have a question, Jose? I didn't really hear a question. No question?
I think he was saying he wasn't as confused this time.
Okay.
Yeah, so
good.
It was pretty hard. It sounded like he was on the cell phone.
No worries. We had a guy at my last job who would take Zoom calls, but you could see like the seatbelt. So he'd be like driving. I don't know if he had like the phone on his dash. And every time I'd be in a Zoom call with him, I was like, bro, don't crash. Don't crash live here on Zoom. You're stressing me out.
It's so crazy seeing people on Zoom calls, like video calls while they're driving. I'm like, don't look at
Yeah.
the phone. Do not look at
Yeah.
us.
People get real comfortable quickly. Any other questions, guys? Great questions, by the way.
And this is recorded, so if if you came in late and maybe you don't get a question answered, you can go back and watch this. It'll be in YouTube shortly after tonight, probably tomorrow morning. But yeah, I think that's great. We spent 30 minutes talking about it. I think that's we got some good questions and answers. So I think we'll move on. Thanks, Guillermo, for everything.
Thank you so much, guys. I look forward to seeing your applications.
Thank you.
Bye.
All right. Well, so like I said in the intro, we're going to be going over some unordered data structures. On Monday, we talked about some ordered data structures, and it's nice because this really will complete all of the data structures and basic data types that we'll be introduced to. And after today, we are going to go over how to loop over and manipulate the data, change the type, and then kind of wrap up those skills that Guillermo talked about. Again, that variable assignment and reassignment, manipulations of strings and arrays, loops, and then key value pairs and dictionaries. Conveniently, as we're going to talk about today, are the key value pairs in dictionaries. So I'm going to dive right into the lesson and get started with it. And I should get through it. We'll see how long it takes. It will get done before the end of class, but we'll see how much time we have, maybe for an exercise or two, or to do something fun with what we just learned. So let me go ahead and start sharing my screen. This will be here. Sure. All right, let me do my basic setup. I think I have to find the chat window. And again, with it, if you have any questions, feel free to interrupt, or you can ask in the chat. Chat will be there to answer any questions. So let me just finish this up. Okay, can everybody see my screen? Yep. Okay.
Yes.
Good.
Yep.
Cool. And so, like I said, we're going to talk about unordered data structures and their built-in methods. And if you remember from Monday, we talked about ordered data structures, and we talked about how whenever we make a list, it will maintain its order. So when you make it, as long as you don't sort it or something else, and using those methods we learned about, it'll maintain its same order, and you can always go back to a certain data point. You can loop over them. You can take a slice of them. Unordered data structures are a bit different because while they're really good at storing data and you can easily find data, there is no specific order of the data when it's in the memory of the computer. And so some of those operations require a bit of work and behind the scenes to do things like looping, and then you accessing the data. It's a completely different way. The two unordered data structures we're going to talk about are sets and dictionaries. Behind the scenes, they work very similarly. They're both hash tables, and you'll be able to see the data, and they're all they're all unique data entries, but you'll see that they're quite different. And I'm going to start with sets because sets. This will be a pretty quick lesson. We do use them, but it's not as common as dictionaries. We use dictionaries way more when we're developing. In the lesson, of course, we have this link. You can look at the sets with a Python source. You can take a look at the source documentation on sets. It can get pretty technical inside when they talk about the data, but it does give you some demonstrations of how to use sets. and then what you can do with them. So it's a pretty good resource to go to. And then, of course, you can just Google Python sets and find several resources on them. But the definition of a set is a mutable, unordered collection of unique elements. That's the definition of a set. And because they're unordered, they're not considered sequences, and they cannot support slicing or accessing a certain thing through an index. But sets do have some attributes where we can use some mathematical operations on them. And I have some nice graphics in the lesson that will kind of explain what we can do with them. And I'll get to those in a minute. But let's just get to how we create a set. The thing about sets and dictionaries, they use the same syntax almost. And what I mean by the same syntax is sets are they're specified with these curly braces. So here in the second Python window, here I have these curly braces and I have some values in between. That signifies a set. And there's only one difference between a set and a dictionary, and it'll become very apparent, but the dictionaries have a colon inside separating key value pairs, while sets do not. If you want to make an empty set that you want to add things to with a loop, for example, you have to instantiate it with the set method, the built-in method. You can't use empty curly braces like you can like with lists with the empty square braces. Because Python will interpret the empty curly braces as an empty dictionary. So this is the only way to instantiate an empty set. And you can run it, and you can see my set is equal to a set, an empty set. When I run this, when I instantiate a set with data already in it, then you still can instantiate it with the set built-in method with your data inside, or you can just put the curly braces, instantiate it, and there we go. We have a set. One of the biggest uses for sets is to deduplicate values. And so that's one of the key features of it. So if I have a set that I have put all these values into, and I instantiate it with all this stuff in there, when I run it, if you notice, it's not the same length, and I only get one of each unique value. So I get only one of these A's. I have two A's in here, and then I have several ones. And so it gets dropped upon creation. And not only that, this is how we can kind of see, how sets are unordered collections. Because I instantiated the set, and I had several ones in here, but which one of these actually made it into the set? We don't know. You don't know which one made it in, which one of the A's made it in. We just know one of them did. So we know that there is at least one of them in our, definition, or if we're casting a list into a set, one of those items will get in there, but we don't know which one. So that's a good way to visualize how sets are unordered, and you don't know, they aren't really in order, so you can't access them with indexes. So that's really how to create sets and kind of some basic properties of sets. Any questions on that so far?
This is minor, but I'm a little confused as to why we use parentheses for an empty one and then braces otherwise. Like, why even have the parentheses at all?
You're talking about these parentheses right here? So if you remember back in the functions discussion, when you have a function, this is a Python built-in method or function. You have to have parentheses.
Yeah, okay.
Yeah.
Cool. Thank you.
Yeah, so that's all that is. It's just the parentheses. It's signifying that this is a built-in method to build something, in this case a set. We do have a few set methods that we can try out here. And they're listed here in this table, but we have the add method, remove method, and the pop method. And so the description here tells you exactly what it does. And then, of course, you can't use indexing. So if you're removing something from a set, you'll have to know what it is, but it'll remove elements. And then the pop will remove and then return, just like we did with list popping. It returns a random item from the set, so you can use it, if you want to reassign it for something else. Now you'll see when like if you try some of these with a set, you'll see that Python still kind of tries to maintain an order in your IDE. So it'll like put things in a set, and then if you pop it, it'll end up usually being the first one in there. But you can't guarantee that. And in previous versions of Python, it sometimes would not pop it, the first one. So they still say you cannot guarantee order, and you don't have order because they aren't assigned an index. But Python will still kind of have that behavior. So I've gotten that question before. They're like, "Hey, I've tried doing this pop thing, and it always removes the same one first, and the second this, and the second, and it goes in order, but you're saying it's not in order." And I'm telling you, it's not in order. But there, because behind the scenes, it's not possible to be in order because the way it's designed behind the scenes. So just keep that in mind when you're playing around with some of this code. You want to make sure you understand that they are not in order. Here we have my set, and we put a bunch of stuff in there. Of course, we return this these values. If I want to use the add method here, I run it, and now if you look, it just kind of put that in there, right? It didn't really put it at the end. It kind of put it in the middle. It's not really in order. But now I can also remove it with the remove method. There we go. It's gone. And then here, the pop command removes and returns an arbitrary item from the set, and you can't specify an index. So if I run that, then it popped out. See, it popped out the one, and then I print the item and then the set as well, just to kind of see what we got back, because I assign that pop value to the variable item. Those are the three methods, or the three set methods we have. And then we have a couple of methods for mathematical operations. But any questions on these three, adding, removing, or popping?
Just to be clear, you said with the pop, I could, for example, do pop parentheses 3, and that would pop 3 out, only if you know what the thing is.
Correct. You have to know
Yeah,
what's
cool.
in the set to pop it.
Cool.
And to be honest, I've never used this in live coding ever. So I'm sure there's an application for it. Just I've never run across it, in my day-to-day job. All right, let's keep moving. Python sets, they support mathematical operations that you've probably seen in math class at times, and you've seen these diagrams, these Venn diagrams, and these are really good illustrations of how each one of these mathematical operations work. And I have a table right here showing the 5 different mathematical operations. And really, one of them is just doing a left or right side. So really, there's 4 because I'm kind of reusing it, but I'm showing the difference between the two. But the first one is intersection. And so what that does is it just when you run you have one set and you run an intersection with another set, it'll just give you the ones that are in both sets. And I can illustrate that here. So we'll have my set, which we know already has stuff in there. I'll add another set. My other set equals, and we'll do it like that. And then I can do my set dot intersection, and see if you start typing a method, you can see how it automatically picks them for you. You can click it, or you can hit enter. You can arrow down to find the right method, and then do my other set. There we go. And again, going back to the Jupyter Notebook, it supports auto completion. So once you start typing in a variable, it'll give you what it already has in memory, and it helps you quickly select it. And then let's go ahead and print my set, and also print my other set. Okay. And if I run that, you have my set here, and then my other set, which I just defined here. And then the intersection is just the ones that are in both of the sets. So it just grabs those. And then we can do my set dot union. So that's the other one. That one returns all the elements in either A or B. So it just combines them all into one other set. Let me see if it will return. It will. So here it just takes all of the entries, still only get unique. So in this case, you can also see like, okay, well, I know I have an A, but which one did it come from in this one now? And so you don't know. It could, it's a mixture, so they're really not in order. So you can't define the order there. And then we can take a look at the differences. So the differences is it returns elements from one set that are not in the other set. So really just getting the unique ones from your left set. Conversely, when you swap the sets on either side of the method, then you're returning it from the other side at that point. So if I do my set dot difference, my other set, and I run that, now it gives me everything that's in my set that's not in my other set. And then the last concept here is symmetric difference. And I'll go ahead and throw this in here. My set dot symmetric difference, my other set. When I run that, now it's basically anything that's unique to only each one of them, but nothing that's shared. So you will not see, it's the exact opposite of the intersection. So these two combined are then the union. Any questions on those concepts? Okay, here's a little more realistic example of using set methods. So if you have, a bunch of employees, and I tried to make it to where it's a list that's a little harder to just kind of eyeball, right? So we have a bunch of entries in here, and then we've had some that have completed. So we have like a system that will say who's completed the training. Most likely the system we had at tracks training will have these functionality already included. But in this case, we need to write, we need to somehow figure out who needs to complete their annual training. So who is basically not in this list. We can take a difference between the two sets and find out. So in this case, we have our big employee set, so all of our employees, and then we have the ones who have completed the training. When we run this, now we have, basically none of these folks in the completed training will be in this set. And so we know who's in there. This is a feature of Jupyter where if you have a long, a long output, it'll truncate it. You can open them in text editors or see a scrollable element by just clicking here. And so now I can scroll through and see. So just for visual purposes, though, it will truncate. Any questions on sets? Because that's really it with sets. Only a few methods, and they're great to practice. But there's really not much to them compared to dictionaries. So we'll spend a lot more time on dictionaries in this lesson. But it is a great way to duplicate. That's something I have used before on the job, where I have a list of things. Let's say, for example, I have a bunch of coordinates. So I have a list of a bunch of coordinate pairs. To find the unique ones, I have cast them to a set to see which ones are the unique values, to help me finish doing something else that I was doing. Okay. Well, with that, since it's pretty close to 7, we can go ahead and take a 10-minute break. Let's just come back at 7:05, and then we will start with dictionaries. I will pause the recording. Okay, welcome back from break. Before the break, we talked about sets, and we talked about unordered data structures and talked about sets because it's a pretty small section. But now we're going to dive into dictionaries, which is more of the meat of this lesson, and the data type that you'll most likely use way more often. And they can be a bit confusing initially, and but going through this and just practicing, you'll learn to become comfortable with them pretty quickly. But just like sets, they are mutable unordered collections of key value pairs. But unlike sets, they have key value pairs. They don't just have a single value. And the keys have to be an immutable data type. So we're talking integer, a string, even a tuple. Anything that's immutable can be used as a key, and then the values can be any data type, even other dictionaries or lists. And we'll go into detail in lesson 7 with those when we look at some Python advanced data structures. So the properties that dictionaries share with sets is they're both unordered. They're also both wrapped in curly braces, and sets must have unique entries, and dictionaries must have unique keys. So you can almost think of like a set is it's a bunch of keys from a dictionary that don't have value associated with them. It's really what they are. It's just a bunch of keys. But in real life, a driver's license is like the best example of how a dictionary works. So if you take a look at like all the stuff on this license, right? We have a license number. That would be the key. You would not have this repeated anywhere on this document because there's only one license number. And so then you have this. And then you have like date of birth, expiration date, issue date. You could have like a name that's not labeled here, but name. And then, you have public J and Q. There could be somebody else with the same name, but their license number will be different. And so in this case, of course, the license number is going to be unique for any driver in Illinois. They're going to have their own unique license number, but some of the other data may be the same. But these keys are all going to be unique when you're looking at one person's driver's license. And so that's really the best real world example of how a dictionary, a Python dictionary work, or a JavaScript object. You'll have these keys and these values associated with them. And then how you access them is with the key. You know, you're going to take a look at this with your eyes, and you're going to say, hey, what's what's the color of their eyes? You're going to go find the eyes key and then know that you're in the right area and look at brown. What's their date of birth? And you're going to take a look. So when let's say she wants to go buy some beer, she hands her license over, they're going to find the date of birth field and then read that and say, oh, you're not old enough, or you are old enough. Here's your beer. It's exactly how it works in real life. And that's exactly how it works with Python. So it is a really great example of how dictionaries work, and you access the value with the key. You have to know the key to know the value. If these weren't labeled, you wouldn't know what their date of birth is versus issue date versus expiration. You could probably assume based on the year, right? But you wouldn't know the difference between the endorsements or the restrictions because they both say none. And so having that key, you access the value so you know. So with dictionaries, we create dictionaries either with an empty curly brace. So like I said with sets, I said the 2 empty curly braces will default to being an empty dictionary. Or you could also use the dictionary method, which would be which would look just like that. So you could also instantiate an empty dictionary just by doing that. Either way works. So here you have an empty dictionary, and then of course with the curly braces. Empty dictionary. So the differences between a dictionary and a set, again, is that colon. So in an empty dictionary, you're not going to have the colon because we have no data. But if you do have some data, like we have here in this English-French dictionary, we have the curly braces, and then we have a key, but the key always comes first, and then we have a colon, and then we have the value. Remember, the key of a dictionary of one entry is going to be immutable data type, so a string is acceptable as an immutable data type, and it has to be unique, and then the value can be any data type. So to the left of the colon is the key, the right to the value, and they're always structured like key colon value. So if you see the curly braces and you see a colon inside, you know it's a dictionary. If you see the curly braces, you do not see a colon separating values, then you know it's a set. So let's instantiate this English-French dictionary. And now we put it in the output, and we have our 3 entries in here. We have hello, and then world, and thank you. Those are 3 entries in our English-French dictionary. Those are the words that we know. And that's how we can see the entire dictionary. But how do we access with Python? How do we access the values? Well, we access the values using the keys. And so like with list and tuples, which we access with the index, we still wrap the key in a square bracket, but we don't put a number unless the number is the item's key. It won't be an index, it'll be the key. So if we're looking at a dictionary, we put the key in there, and then what Python returns is the value. So we pass it in, we pass in the key to get the value, and then we can see it. So in this first example here, we have our English-French dictionary. We want to see what is the French word for the English hello. So hello is our key, the English word key. I want to see the French word. If I run the cell, I get back the value for that key. You use the keys to return the values. So then we get bonjour is our return. We also know that dictionaries are mutable, so they can be changed. So we can also add or reassign a value using the key. So in this next example here, we have an assignment operator. So we're going to put, to make a new entry into a dictionary, we still write the dictionary name because we want to add something to it, but we just make a new key in the square brackets right here. And then we use the assignment operator to then assign whatever value you want to that key. So from before, when I would call it, I have these 3 items. I add it here by using the square brackets, and I put my new key that I want, and then I use the assignment operator and put in the value. Now, if I run it, now I have my 4th item here is goodbye, and it's au revoir. So we have those items in there now. We can also overwrite. So if we have a key already, the key of hello, we can just reassign it by using the same assignment operator, the single equal sign. And now what I'm doing here, and I'm assigning it, because there's another way to say hello in French. We can say salut. So I'm like, oh yeah, that's right. I want to add that to my words for hello. So I can just reassign it here, and using the assignment operator. When I run that, now I have hello, the key of hello will return the list showing bonjour and salut. So Alexa's asking, could bonjour return hello, or just hello returning bonjour? Right now, our keys are the English word, and our French words are the values. You use keys to access values. You don't do it the other way. That doesn't mean you can't see, like, let's say you only knew a value, you don't know the key to it. Doesn't mean you can't see it, but you'll have to use a creative way to kind of see the data, which we'll talk about in the next lesson. Tomorrow's lesson, we'll talk about loops, and I can even go over a little bit here in this lesson. But just remember, with a dictionary, you're using keys to return values. You'll structure your data in that way. If you need a French-English dictionary, then you could have that and then have it the other way if you want a new data type. But you can see values without keys, or you can see key value pairs using the methods I'll talk about a little further down this lesson as well. But you can only access the values with the keys. So, and that's going to be one of the hardest things to kind of think about with this data type, and wrapping around, like, why does it work this way? It's because it's an unstructured data type, and once it just clicks with you, you're like, oh yeah, that's why it works this way. It's super powerful. So yeah, just kind of remember that you use keys to unlock the values, and you have to reference the values. To get to a value, you have to use the key for it. So, and just, you know, different ways you can structure data, like the driver's license. You know, when we look at like databases, when we have a user like your Facebook profile, right? Just, you know, your user profile looks just like this driver's license, except there's a lot more data points that they are recording about you. But it's going to be structured just like this. You're going to have your unique ID, and then your name, your date of birth, and, you know, what you browsed yesterday, what you talked about with your friend, with your phone in the other room, so on and so forth. It'll all be recorded in that database. But you know, just remember that you use the keys to access the values. Any other questions on the intro, you know, how to start, you know, adding values, changing values in the dictionary?
Pretty straightforward.
Yeah, it is. And let's think about this, because this kind of takes us a bit into, you know, that you know, nesting, if you will. You know, what if I only want to return salut, right? How would I do that? If I know I'm gonna need to reference my dictionary, right? And I know that I'm going to be using the key of hello to get to the value, right? But I don't want to see bonjour. I just want to see salut.
That one you can index because it's a list for the value.
Yeah, it's indexed,
Yeah.
right? So then I can say, well, you know, I could, if I want to return salut, then I just need to do either index of 1 or -1, because it's the end of the list. So let's use negative indexing. And I run that, I get back to loop. So that's just using, going to one data type, and then once you get to the value, you have to start drilling into the actual values. And you can have multi-tiered, when you're looking at JSON data, that's exactly how it's structured. When you convert JSON back to dictionaries, you may have to do several drilling to get to certain things, or multiple loops to kind of get through the data to parse through it. There's a lot of libraries now to help with that. But if you don't want to use the library, you can use multi-tiered loops and everything else to get to your data you need. But yeah, that's exactly how you would do it. You want to access this one, you want to access bonjour, then index 0. Run that. Now we have bonjour. You can delete a key value pair using delete keyword. Just remember, like when you do it though, you're deleting it permanently. There's no confirmation. There's no "Are you sure?" You run that. Method, and it'll be permanent. So if I run that now, I got rid of that key value pair for world. It's gone. It's no longer an English-French dictionary. So you can use that to just get rid of one key, the key and value pair, just by using this command here. You use delete in front of it, or del. Next, we have the keys and values methods. So you'll use these a lot. I use these probably every day. Same with the items, which we'll talk about here in a bit. You use these as well to iterate over a dictionary. So when you use this method, what it does, since you can't just iterate over a dictionary, I mean, you can, but behind the scenes, it's going to put it into like a list-like object and iterate over it. In its native form, it can't do that. We use these to iterate. And so if you use the keys value here, it's going to return this dictionary keys object that looks a lot like a list inside. It's not a list all the way. So there's some things you cannot do unless you cast it, but you can iterate over it. And that's the important part. So when you iterate over a dictionary, it's going to grab the keys and iterate over that for you by default. And you'll see all that in the looping lesson tomorrow. But when you run the .keys, you'll see all the keys in the dictionary. And then if you run the values method, that gives you all the values without the keys. So in this case, we start off with our, nested. We have their first item is that list of bonjour and salut, then merci, then au revoir. We don't know what English word those are tied to because we can only see the values, but use the keys method to get the keys, and the .values method to get the values. And then lastly, you can see the keys and values together in a list-like object of tuples with the items method. Again, we will use these methods again, all three, when we go over iteration next lesson. But here we use the items, and now we can see that they're kind of organized in tuples. And we can iterate over these. So we can use this. This is probably the most common way you're going to iterate over a dictionary, because you're going to want both the keys and values. So when you do that, then you'll iterate, and the first one you go over will be this one, and you'll have key and then value assigned to two variables, and then you can use those in your loop to do something with your dictionary. And so I promise it'll become super clear once we go over it, because we're going to get a lot of practice using these methods to iterate. These other methods that we have, if you were to try to access a dictionary and does not have the key, you'll get an error. And sometimes you don't know what values or what keys are in a dictionary. So we have some methods that will help you determine what's inside of a dictionary, or to see if what you're looking for is in a dictionary without returning an error. And that first one is the .get method. So when you use that dictionary .get, you'll put your key that you want to return, and then you also put a default value. It may not be present in there. You probably want to put something that's not in there, right? But you want to put some sort of message, something saying the key was not found, and you'll use that, in your script to access the data of the dictionary, and see if you have the key that you want in there. Sometimes you're going to know, sometimes you're not, if you're looking at data coming in from another source and you're trying to iterate over it. So you use the .get. So let me go ahead and add a code block, and we'll say English French dictionary .get, and then we're gonna put in hello, and then by default we'll say not found. And if I run that, of course, I do have a value associated with hello, so I'm going to get back the value for hello. But in this case, let's try library. And I run that, not found gets returned. If I try to do that without using it, so if I just want to access the key of library and run it this way, I get a key error. You're going to see this a lot, spoiler alert, because you're going to try and access a key that's not there. You'll see the key error a lot in your learning journey with Python, but it's pretty explanatory. Key error means, okay, the key, obviously there's an error with the key and it's just not there. So that's why we use the get method. It's a little more friendly, right? It's just not found. It doesn't end, like this will end your program. And so you won't be able to go further into your program if something's not found. Let's say you that's a step in your program, you just want to see if something's there, but if it's not, you still do something else. You need to use the get method, and you don't want to just try and access a key that's not in the dictionary, because it will just give you an error. The same with the pop. You can specify a key with the pop method, or if it's not there, you can default a value. We can do that. The pop item will just return an arbitrary key value pair. You'll find that it will tend to do the first one in these later iterations of Python, but just remember it's still defined as arbitrary and at random, but you can use that as well. Let's try a couple of these here. So English French dictionary .pop, and we'll do the hello. Oh, gotta do the string, and then run that. Now, if I take a look at English French dictionary again, hello is no longer in there. I popped it out, so it's no longer in there.
I have a question. I was wondering about this prior to you. I was hoping you'd explain it, and kind of did. When you do that, is the hello key just getting cached, or is it like in the ether somewhere? Like, how does that work?
Oh, it's gone now. Now, if I would have assigned a variable here, right? So let's go ahead and put a new code block in here. Yeah, so if I French dictionary, and I'll do hello, and then I'll do equals. Let me just copy and paste this bad boy right in here. C V, and run that. Okay, and now I say hello popped equals like that.
Mm-hmm.
So I run that, Now it didn't return, it's assigned to a value.
Mhm.
But now I can look at hello popped. At least I think I can, and run that, and there it is.
Okay.
Yeah,
Nice.
so it's no longer in the English French dictionary, but it's still, I could still save it. So popping is a good way to, if you need to use something for later, you can save it to new variable and then use it later as you need. So update is used quite a bit. So that one here, you can give it just a key value pair you as a form of a full dictionary. So you need to have the curly braces and everything else. But if you have one dictionary and then you want to add another dictionary to it and just kind of mesh the key value pairs, you can use the update method to do that. So let me go ahead and run this back in here so we have it back. Yeah, I have it further down here. So run this, and then of course the clear method will clear out your dictionary. So if I run this here, now I have an empty dictionary again. Okay, but now I have a bigger one, a new English French dictionary. So let me go back. I'm going to instantiate my other dictionary again. Let me see here. I don't need to instantiate right now. It's empty. So I run this, and I have a new English French dictionary, which has a lot more stuff in there. Now I can populate. So I have my empty dictionary, and then I have my new English French dictionary, which has stuff in there, right? It doesn't have salut for hello, but at least has something. I can run the update method here, like that, and now English French dictionary has everything from the new English French dictionary in it. So using the update kind of just injects it into the dictionary. And so this is just another example of all the items. I'm popping hello out. So it's gone now. And then I try and get it with this, not found. And then I can also just pop out a random one. Here I use pop item and it pulled out the last one. So I recommend just playing with these, just kind of trying to manipulate a data type, build a dictionary, and then try and mess these dictionary methods to figure it out. Any questions on these dictionary methods? And we're going to use these in conjunction with loops to really manipulate dictionaries and do some cool stuff with them. Because you can use dictionaries to count items, you can use it to do all sorts of stuff. And so using the loops in conjunction with these dictionary methods will make it a lot easier to kind of see. So yeah, any questions on these methods right now?
I hate to keep bombarding with questions, but I'm
That's,
assuming when you do update and there's a match of keys, it'll just populate the value to become a list.
let's see what happens. That's a good question. So let's do this. Let's
Like if you haven't cleared hello, for example.
right. Yeah, so let's
Or
instantiate the new one here. Let me see. I mean, this should be fine. So let me do this instead. Equals, grab this from here. Okay, run that. There we go. I have it in there, right? And then I want to change hello. So I'll do hello equals. I don't have the list up here somewhere. There it is. Okay. I can just run that again. Okay, so now I should have it. So if I were to take a look at it here, make a new code block, English, French dictionary, run that. Okay, so hello does have now the list, right? And so you're saying, what if I were to update it like with this, right? So I have English, French dictionary to update with the new one. Okay, so let me run this real quick and then run that. Got rid of it. So it overrode it.
Interesting.
Mhm.
Okay. Cool.
Yeah. So it'll override it. If you have two items you're trying to assign a dictionary with two items of the same key, it's going to take a random one as the final value. So that's just like a set, right? When you have two or three ones, you're trying to cast a list into a set. It's going to grab one of the random ones and put it in there. Same thing will happen with dictionary. You can only have unique keys in the same dictionary.
Yeah. Okay.
Please ask questions. That's what we're here for. That's the whole purpose of this class is, to get your questions answered, learn this new stuff. It's a new skill. But it's, yeah, ask away. Okay, let's move on. We're actually almost at the end of the lesson, which is nice because then it'll give us time to try some exercises, do some other stuff with these dictionaries or anything else that we've learned in the past. So I did put in some common operations across data structures, not just sets and dictionaries, but they also work with lists and tuples. But we have these we have max, min, sum, and length. You've seen this one before, right? The length, you have the return number of elements in a collection. But when we run that on a dictionary, what do we get back, right? So what's the length of a dictionary? Do we count the keys? Do we count the values? Do we count the key value pairs? Which one is it? It really could be all of them, but it's going to count the keys for a dictionary. Because you may have multiple values. You could have like one key represents three different values in a list. So it's going to count the keys for a dictionary. So we have a set here with some values here using the max, right? So we take a maximum value contained in the collection. If I run that, Z16 is going to be the max in this one. We're looking at strings. And again, that's going to be referencing those ASCII tables for that first value, right? So Z is going to be the highest value in there. And so Z will count as the max. Of course, if you have numbers in a set, it's going to take whichever the highest number is. The min is going to do, it's going to find the lowest value. In this case, we have A as the first letter, so that's going to be the lowest. That's the minimum in this example. In this set. And then with the sum, of course, this will just do a quick arithmetic and give you back the sum of what's in the list. Of course, you can mix data types, but if you try and do that, you throw a letter in there, it's going to give you type error because you cannot add an int and a string together. So here it can't, whatever the value is, it can't add it to a string. So you're going to get a type error with that. So in that case, you're going to have all numbers in your collection. With dictionaries, again, when you look at the length, I can run the length method and see that I have 10 items in my dictionary. And you can see, remember, looking at a dictionary, you have your curly braces, and then you look at your item, you see a colon, you have a dictionary at that point. Some are organized like this, some are organized more neatly in like a vertical fashion. We have ways to just automatically do that with coding software like VS Code. With sorting, when you run like the sorted method on a dictionary, it's just going to sort the keys. So what it's going to do is return a list of the keys and do what you need. When you have this reverse flag in here, it's going to put in reverse order. So And that kind of plays into the dot keys, dot values methods I introduced up at the top up here. When you run the keys, you get a list type object. It's not a list, but the sorted method will then cast whatever came back from that as a list and then sort it and then reassign it. So a lot of stuff goes on in the background with that one to give you the result here, which is the sorted keys in a list. Any questions on those? That is the introduction to sets and dictionaries. Didn't go over too many exercises, but that's okay because we have an hour and 15 minutes to do that. So again, it may not be very clear now, and then thinking about how you're going to access the values using the keys. Well, what if I just want to see the keys, or what if I want to use the value to access a key? You really can't do that. But when you think about the data structure, and especially when you see more uses of it, it'll make sense as to why it's structured the way it is. And it doesn't mean you can't get to a key from a value. You just have to do it a creative way, typically using a loop. And we'll go over that. So we do have 4 assignments in here, and they're pretty good. I can start off and just kind of explain each one and go over them. And so here, the first one called number of characters, it says write a function that takes in a string of lowercase characters and returns an object containing the count for each letter in the string. And so this is using the power of dictionaries. This is a pretty good one to do together. So we'll probably do this one together tonight so we can see it. So in this case, in this example, it says print, the count characters. That's, if you remember from functions, we define the function here. So we have the def keyword, then we have the name of our function, and then we have our parameter or argument. Okay, so it takes one argument. In this case, it says takes a string of lowercase characters. So we now know we have a bit of computational thinking, concept to think about. Okay, we have a string of lowercase characters, so it's not going to be uppercase, not going to be numbers. And it's going to be, we want that as the parameter. And then inside the method, right, we're going to write that to get an object or a dictionary containing the count for each letter in the string. So if we take a look at B, D, A, C, D, A, A, we have one B, and then we have two Ds, we have one A, or three A's and one C. And then what we want to do when we have this is we want it to give it any string of lowercase characters and then return back a dictionary that contains the counts for that, whatever it is. So when we call the method, we no longer care about what's inside the method. We just care that it gives us back this. So just like we go into just like we go to like the store, we go into the store, we give the cashier some money for some items, right? Let's say we didn't do all the math in our head, we just know we have enough money to cover what this amount is. We go to the cashier and they ring up all the items. We expect them to kind of give us our change, give us our items. So we want to make sure we get the right amount of money back. We don't care about how they do the job, as long as they do it correctly. We get the right amount of money back, and the receipt. We get the receipt too, and we can take a look at if it was accurate. That's the same thing happening here with the function. So just a bit of review on functions and how they're structured. So let me go ahead and fork this over real quick. And then instead of doing it here, let's go ahead and copy this and put it into our Jupyter notebook. There we go. And then I can open up these as well. We can take a look at those and we'll go back to solving it. Yeah, these challenges are going to test you a bit, which is good. I think these will be good for you. And so this kind of almost gets into, object orientation, but not really. But it explains like how you can have attributes of something and you can change them depending on what's happening. So in this example, it's a car trip, and it write a function that takes in a car object in the form people, miles, spare tire used. So we have the keys are going to be people, miles, and spare tires used. And then a number of miles driven as an integer. So those two things, the actual object itself, so this whole thing is going to be one argument. And then the second argument is going to be the integer of the number of miles driven. And so here we're saying, okay, example, the road's very rocky, so you need to use an additional spare tire every 1,000 miles. So those are some pretty cheap tires, but you need to use a spare tire every 1,000 miles, and then you want to update the car object to reflect this too. So there's a lot of stuff going on behind the scenes, right? So we're going to have, in this example, our car trip, we're going 5,500 miles. When we put these two things in there, our output should be just a single object, but now we should have how many miles we've driven and then how many spare tires we've used. So this should be somehow calculating it based off the information given. And so we need to write some logic here that does that based on the information that we're given in the explanation. If we can get to this one too, it'll be good, because this one kind of really help you see how you can manipulate data with input data. Okay, next is how much will you spend? So given a dictionary of items and their costs and an array specifying the items bought, calculate the total cost of items plus a given tax. In this case, I believe, actually, let me see, socks and shoes. Yeah, I believe this tax is not a percentage, but this is actually an amount. So just keep that in mind. So, and it says if an item doesn't exist in the given cost values, then the item is ignored, and then the output should be ran in 2 decimal places. So you have your function get total, you get 3 arguments, you get your costs, then your items, and your tax. When you take a look at the cost, so item costs becomes costs inside the function, and then items becomes this list of stuff, this list of strings, and then your tax is your tax amount. And then when those go put in there, when you put those in there inside the function, you should calculate and you should return the float of the output rounded 2 decimal places. And so if you put like jacket or something in here, if jacket was put in here, it would be ignored. So it's only the item cost here. And then lastly, this scenario is you're a new programmer at your company, your CFO needs some data regarding all the employees. So it needs to know the number of employees per job title, average salary, average bonus. So we're using those methods to kind of calculate average using the sum and using some division, some arithmetic, and the average total compensation for that job title. So you get a list of them, and then the solution should come up with something like this. So just note, looks like there's a kind of a weird typo in this one. So if, you won't get a true unless you name your average total comp AVT total comp. So it looks like a typo in the exercise itself. So just keep that in mind whenever you're doing this one. You may you may be confused as like you may see the values, whatever, but it's like doesn't equal it, like because your keys may not match. So just keep that in mind. Looking at the solution data, just make sure your data lines up with it. But yeah, we can probably go this one to tomorrow, probably before the lecture. But let's go back to this one. Let's go back to the first exercise. Let's go ahead and take a 10-minute break before we really get into the exercise, because we almost been at it for an hour. I'm gonna go ahead and pause the recording. Resume the recording. All right, welcome back from the break. We're going to go over the first exercise. And what's nice about this exercise, it actually is one of the things you'll want to have in your back pocket when processing data. And so understanding how to write this kind of function is pretty important. And you use it, especially if you get into like even like the data science stuff. So cleaning data, just understanding how dictionaries work and counting can be useful when cleaning data or doing some other processes. So in this case, we're using the first number of characters exercise, and it's write a function that takes in a string of lowercase characters and returns an object containing the count for each letter in the string. And so if we go back to our computational thinking and our problem solving techniques, we want this to come in, and then we want a dictionary to come out with all these counts. And we can kind of look back at our some of the processes we've learned, and some of the things that we're actually going to learn tomorrow with looping. We may have to loop over this or something to take a look at the characters, but we could split this. We could split the string. We can take a look at the indexes without a loop if we needed to. But we're going to go ahead and probably use a loop to kind of go over each one of these characters to take a look at it and then do something. And so we're going to start utilizing those dictionary methods that we had as well to kind of get these letters into a dictionary and figure out how we're going to start counting them. So a good plan of approach that I would take when I solve a problem like this is, and typically what I do when I write a function is I want to return something, right? So I'm going to have a return statement, but I want to define what I'm going to return. And then I want to start manipulating that item. And so I'm going to just call something result. Okay. So result, and I'm just going to make it, I know I have to have a dictionary. So why don't I just make it an empty dictionary? And so I know that I'm going to be doing something and adding stuff to this result. And so now let's think about, okay, so I want to process the string. So now string in this first example becomes BDACDAA. That's what string becomes. And so inside the scope of this function, to get this stuff, I just need to reference it by using str. Okay. And so so I want to maybe loop over str and look at each letter. And then when I look at the letter, I want to do one of two things. I want to either add that letter as a new key in this dictionary, or I want to see that letter already exists and then increment my value up. Those are the two things I want to do when I'm looking at my result as I'm looping through this. And it doesn't matter. And let me comment this out here. And then I'm going to do this. And comment this. And then a special character. this. Let's do this. It's all lowercase, right? I think it was all lowercase. This is awesome. I'm learning about Python dictionaries. Cool. Okay. What's happening here? Print. Oh, that's why. Close my parentheses. There we go. Okay, so I have now I'm writing this function to take in any of these and still give me a dictionary that applies to each one of these strings. So I want to loop over the string and look at each letter, and then I want to either do one or two things. I want to see if the letter exists in the dictionary as a key. And if it does, if it does, I want to, if that letter exists in a dictionary as a key, then it already has an associated value, right? And so that value will always start with what number? Yeah, so I want to increment. Yeah, so Thomas says increment the value. And then if it doesn't, wrong character. Wrong character again. There we go. If it doesn't, I want to establish the letter as a key and assign the value as what? To 1. Because then I know once I come across a letter and it's not my dictionary, well, then now I know I have one of these letters. So I want to establish that as 1. Okay. And then I just want to just do that. So if it does exist, I want to increment the value. If it doesn't exist, I want to establish letter as a key. So cool. And then just return the result at the end. Okay. And so I'm sure as most people had exposure to for loops yet, have you all looked ahead and kind of taken a look at the lesson? We have several types of for loops, and I've shown already one, but we have a typical one. It's a standard. So for item and undo letter. Yeah, some previous studying. So for letter in str. So for letter in string, because we know it's all lowercase. So this is a really good descriptive variable for the letter. So every time this loop iterates, it's going to grab one of the letters from here. So for letter in string. See if the letter exists in the dictionary as a key. So how do I do that? How do I see if something exists as a key in a dictionary? Is there any are there any dictionary methods we could use?
Get.
Oh, we have the get method, right? So we can say, okay, well, then the dictionary we're using, what dictionary are we referring to now?
Have we defined it yet?
Result.
Yep,
Oh,
we have.
there you go.
Here, so result, right? So result dot get, and then I want to say that's letter. And then I don't think I have to have a default, or do I? I don't even know. Let's see. or default value. I mean, I guess I can just have empty string as default value. Or better yet, I need to have a result. I need to have a default value, and let's make that default value none. And we can say, I'm going to make this, very lengthy just to make sure we're covering every step. So this isn't going to be the most efficient loop at all. But we're going to say checker. So let's do letter check equals. This is where I'm like really unnecessarily assigning a variable. I just want y'all to see the process. So letter check now equals result get letter. Or we'll get back either the value from my check of that dictionary, or it's going to give me none if it's not there. And so now I can say if not letter check. So in this case, what I'm saying is if I get back none, if letter check is equal to none, this will evaluate to true. Then I can say result letter equals 1. Else, because I only have one other option, right? Else result letter, and then how do we increment?
Can you do plus equals?
+1.
Yes, we can do plus equals and then just 1. You could also do result result at the key of letter equals result at the key of letter plus 1. Either way is the same thing, but typically you just want to do plus equals. So it's plus equals 1. Thomas, are you talking about on line 15?
On line 17 is what I was talking about.
Okay, yeah. So basically what I'm saying is I'm making letter check, and I'm either going to get back a number or I'm going to get back none. And then I'm saying if not none, so if not none equates to true, I don't think it's right. I think it's, yeah, that's right. So if none, then I want to establish it. Otherwise, I want to increment it. And then I want to return result. And then I'll comment these out. And let's see what happens. Okay, it looks like it worked. So then I can comment this one out. And I can do this one, see what happens. Okay, so it's an S and then 1, D3, F4, and I can go in here and count. It's really hard to count them all because you're starting to get a really long string. So it looks like it's working. I can run this one here. This one's even longer. And a more concise way to do this, you can, you don't have to use the .get method, but you can check to see if the key is in there, and then still it looks almost the same as this, but this is a way to really break it down for you, where you can see, you can see that you're assigning a variable, and it's either going to be a number or none. And then what I want to do is I'll probably do this example. So let's do this one. I guess we can leave all these commented out. And I'll put this over into Python Tutor so we can see how it actually looks. So Python Tutor. Okay. All right, so we have our comments in here. Let's go ahead and get rid of these comments because we kind of know what we're doing now. And then we can leave the rest. Now we can visualize the execution. Okay, so we have 99 steps. By the way, I think this one caps you out at 1,000 steps. So if you have like crazy nested loops, you may have too many steps and it will just freeze on you. So just keep that in mind. I mean, it's a free REPL, so they kind of cap it. So, but it is good to see stuff for like learning in this context. So let's just start with the we have a definition. So we have a function called count characters, and then we're going straight to the only uncommented line which calls the function. So we wrote what's in the function, but now when we're calling, we don't care what's in the function. We just want to get something back that, you know, from this input that's correct. And so we go into it, we call it, and now we're going to go into the frame of count characters. And if you look here, we're now this is like isolated from the global frame, and inside we have a variable called string, and it's now equal to what we put in as the parameter for the function. And then we're making a new dictionary, a new empty dictionary called result. And then we're going to start a loop. And for each letter in string, so our first letter is S. Now letter becomes the variable S inside the function scope, inside the loop, the scope of the loop. And we're running letter, we're going to define a new variable called letter check, and it's going to check result and do the get method on result to see if we have letter as a key. Well, the first time this runs, we definitely don't because we have an empty dictionary, and it says so right here. So it's going to then say, when we say if not letter check, we're saying if not none, yeah, so if basically if I don't get anything back from the get method, I want to do the code inside of this this logic. So in this case, we're making now our first key called S. So result letter, so result, and remember letter is S. We want to make it equal to 1. And then we're done because the next logic is an else statement. And we didn't get to that because we went into the if statement. Next, for the next letter, that's the same thing. So it looks like we have all unique letters until we get to this D here. So it'll basically, for every letter, it's going to do the same logic for every iteration as we go through. So keep going. We have L, K, G, J, and then A. So it's all making these new keys. So each time this loop iterates is making new keys. And then here now we do have D already exists. So it's going to check here first. And then nope, it needs to go to the next one where we increment it. And D gets incremented to 2. So that's what that plus equal is. And then you can run through. We either get a new key, or looks like I typed a lot of the same letters. So we're getting a bunch of increments right now. I think the B is coming up. That's a new letter, right? Yep, so there it goes. And then we get to the end. And that's the return value, is this dictionary. Here's that 413 steps. Which one did you use an input?
all of them. Yeah, just I made a bunch of print statements like you did, and
Yeah.
just let them all run. I mean, they came back with counts and stuff. So
That's cool. So that's really how you would do that first exercise. You know, to use a dictionary to count things. It's a pretty common operation. So that's a good exercise to do and get used to. Let's see, we have 30 minutes. We could probably start diving into the car trip one if y'all want to. Let me see what I have in here. Oh yeah, I was using this for the AI stuff. Let me get rid of that. Just testing out some chat GPT responses for the YouTube video. So let me see here.
Aaron, are you using 3.5 or 4.0, the paid one?
So I think when you're hitting the chat GPT API, you're charged regardless.
Right, but do you use 4.0 or 3.5?
So the script was usually written with 3.5, but I wanted to see if 4 came back with some better descriptions for the videos, and so I like threw $10 into the thing. It's like it costs like a couple cents to run a prompt, or not even. I think it's even less than that to run a GPT-4 Turbo response.
I heard the difference between the two is that the GPT 3.5 was given a bar exam to pass, and it finished in the like 7th percentile, so not very good. But they gave the same bar exam to the GPT-4, and it finished like in the 96th percentile.
Huh. That's
so
great.
significantly better.
Yeah.
But it depends on what you're doing, I guess.
Yeah. Yeah, this one here, we have like an example prompt, and it's like make it apply to this lesson. And like, so I have like a JSON object that has this lesson kind of broken down into separate topics, and then it just spits out a response. And I was trying to mess with how much like it varies between responses, and I was using 4 just to kind of see what you can do. But yeah, the lesson 4 video has the description I used with ChatGPT 4, I believe. So but it looks a lot like the other lessons too that Platoon offers. But yeah, you can take a look. It's pretty cool. It's a fun experiment, and I've been tinkering with it and improving it, trying to see what else we can do with it. So, because we do a lot of other videos and other things too with our other teams that we have. So, so here I threw in this. Oh, it's in a markdown. So by the way, when you're looking at Jupyter notebooks, you have different types of cells, and you can change it by just clicking on the letter in the lower right, or the description in the lower right, and you can change it to whatever you need if you have it installed. In this case, I do have Python installed, so I just changed it to a Python, and now it looks more familiar with the comments grayed out, and then the typical coloring for a Python code. So here it says write a function that takes in a car object. Again, I've described this already, but I have the three parameters, or the 3 keys. We have people, miles, and spare tires used. We know the road's rocky. We know that we need to change the spare tire every 1,000 miles. And we need to update this car object to reflect these things. And so we have a couple things to think about when we have our car object and we have to take this here. We're like, okay, so what do we do with these 2 parameters to kind of manipulate it to where it returns the object with the correct calculations? And if we take a look, we have 3 keys, right? We have people, miles, and spare tires used. What are we not going to use at all? What can we just not even deal with? What's never affected by the trip, if you will?
People.
Yeah, the people is just going to stay the same. So, that's kind of like data that's just going to go in and come back out and not be changed. So we don't even have to worry about the people. Maybe this is like a first iteration of something that we will be messing with people. Like maybe when you add people, then you change how much you have to change a spare tire because it's more weight. you could write more functionality with that, but now we're just going to deal with the miles and the spare tires used. And so when we're looking at this, we take in our car object and we're like, okay, inside of our method, what do we do with that? What are we going to evaluate first? How can we break our bigger problem of changing all this stuff? Like, what smaller problems can we tackle as we are looking at the input data?
You start with changing the odometer.
Okay, so just change the miles. Okay, cool. So we have that. So we can say, okay, well, let's start by changing the miles, and that seems pretty easy. How do we do that?
Start with the first parameter, car object,
Okay, so we'll say car object.
the name of the object.
Okay, and we're messing with the miles first, right? And then we want to like change it, right? We want to change it to where if we drove 5,500 miles and we have 1,500 miles on it, we want it to be 7,000 miles. How can we make sure that's always going to be the result of whatever input because the input could be different. Like people could be different people, and miles could be starting miles of 30,000 miles, and we've driven 20,000 miles. Like what can we write here to make sure miles is always going to reflect a change from miles driven?
The increment miles underscore driven. Plus equals.
So here do plus equals miles driven. Right?
Right.
Okay. And we can always do this too. We can always print. We can use print statements just to be sure we're doing that correctly, because we're kind of we're doing one thing. We want to see how well it works. So we can say car object and then print car object. We don't have to return anything right now. We can just print it out. Hold on. Sorry about that. I had to kick my barky dog out of the office.
Aaron, could you even zero in on the miles key of the object itself when you print?
We can. Yeah. Let's stick with printing the whole object out though, just to kind of see it, right? So we can do like this, car object before. And then we can do it like that. Right. And I think here we need to comment this out. Just write a new one here. I think we have to print anything, as we're printing things already, so we can just call car trip, and then put in these things right here. Let's do I'm going to make it a little more visually appealing. There we go. There. Okay. make things a little easier to see. All right. Oop. Yeah, select Python. Okay. So I ran it, car object before, here's my object, and you see miles has changed to 7,000. That's the result we want. So it looks like doing that worked. If you notice, inside of our function, 0 numbers were used. That's what you want. That's the kind of code you want to see. You don't want to see a lot of hard-coded values unless you need them for certain purposes. But this is the kind of code you want to see whenever you're changing stuff, when you have your input data. You want to try and use variables when you can. In this case, we are using variables. We're just incrementing it by the mile driven, giving, that's from the input. So that worked. So now we can get rid of those print statements. And now we can just move on to the spare tires used. And so our end result in this case, we're riding every 1,000 miles. We're driving 5,500. So this says we're using 5 tires used. That makes sense because we drove a little over 5,000 miles. So what can we do to make sure this works for any kind of miles value? I think we're going to use the same kind of process. We're going to reference our car object, but then we're going to reference what key. Looks like spare tires. Spare string. Spare tires used. Then what are we going to do here?
Do the miles divided by 1,000. Something like that.
So divided by
1,000, right? And increment per 1,000, right? Something like that.
So right now it's 0, right? So we haven't used any. So if I called this right now, it would come back with 0. And so
we don't want to divide that by 1,000 for sure. How about if we create a variable called tires used or something like that?
Sure. So tire, or maybe like a tire calc.
And set that equal to what Emerson was talking about.
So
miles driven divided by 1,000.
So miles driven divided by 1,000.
Now, Aaron, will this give us a float?
Let's see. Let's print it out. This is what you can do when you're coding.
And if it does, is that acceptable?
Can you use part of a tire? I guess.
So I feel like we're going to have to do that double slash, that integer division.
So yeah, so we got back 5.5. See that?
So
we can't use, you can either use a whole spare tire or not use a spare tire. You can't use half of a spare tire.
So slash slash slash.
Yeah, that's called what again?
Integer division.
Floor division?
Integer.
Yeah.
Because it gives you back an integer.
Integer division or floor division is also what it's called.
Yeah. And it truncates the decimal.
It gets rid of that, right? Gets rid of the remainder. Yeah. So then we can see tire calc. Oh, we got back 5. Sweet. So now we can say
plus equals
tire calc. Yep, because we want to increment it. Because if we already have, like, let's say we do this calculation, we'd already used some spare tires, we don't want to reset it. We don't want to make it equal to. We could make it equal to, in this case. We could just say equals. But if this car goes on several trips using this method over and over again, you want to make sure you're incrementing so you're your beginning state is salvaged. So, okay, we have that. And then we can, let's go ahead and just print. We can just print our object.
Hello.
Hello.
Sir, I have a question. On those back or the front slashes or the slashes, it just gets rid of the decimal. It doesn't round down or up. It just gets rid of it. I just want to make sure, clarify.
It just
Okay,
takes it
awesome.
off. Yeah. So in a sense, it always rounds down. So if you,
Okay.
because if you just cut off the decimal point, you're always rounding down.
Okay.
Yeah. Run that. Now we have people spare miles 7,000, spare tires used 5. So there we go. We can then get rid of that. And we can even move this up here just to have it, you know, a variable we defined in the beginning, and then we do our data manipulation there. And then at the end, we print our car object. And this should work for any kind of input data. So here, let's say we went, you know, 35,000 miles. And we've already used 36 spare tires. Then we can run that. And now, if we look here, we've driven 5,500 miles. We've incremented up by 40 up to 40,500, and we've used a total of 41 spare tires because we added 5 more to that. If we made this 35,000, now we're doubling the life of our car. There we go, 70,000, and then 70 spare tires used because you're using every 1,000 miles. Any questions on this exercise? It's really important that when you're taking a look at these problems, these functions that you're writing, you're really thinking about, you know, how you're defining it, and then really how am I going to solve this problem using these tools I was given when it comes to using, you know, integers. Here I actually did hard code something in there, but that's okay because it's meant to make the variable. So then I'm not actually putting a value in here. I'm using the value that is driven off of this calculation. So this is still pretty clean programming. Any questions at all? I think we'll stop there. We only have 10 minutes left, but you know, if there's any other questions on the lesson, what we've learned in the past of the past 4 lessons previous. You know, I took a look at the and I can go ahead and stop the recording. We'll stop.